So I made homework 1 available over the long weekend. It is due on Friday. It's a very short homework, so it shouldn't take you long. Future homeworks will be available about a week in advance. This one, of course, you only got your accounts maybe yesterday or today, but it's an easy homework. It should only take you more than an hour, maybe 2, if you're really laid back. So, if you haven't managed to get an account yet from your TA, it's very important that you try to get one as soon as possible so that you'll be able to submit the assignment. You need your class account to submit homeworks. So please contact your TA, or even if desperation, any TA, get into class account for it as soon as you can if you don't already have one. Question here. It is due right before class on Friday, so 4 p.m. is the deadline. So today's lecture is going to be on several things, including if statements and the return statement and Boolean values, and we're going to start off with primitive types. So I started off the lectures by talking mainly about reference types, but Java has primitive types as well. So the difference between primitive types and reference types is references point to an object somewhere. Primitive types are just very simple, basic forms of data like numbers or characters or Boolean values, which means true or false. And so here are some of the basic number types that you can use in Java. You can declare a byte, which is an 8-bit integer. And for those of you who don't know what an 8-bit integer is, which is really a CS61C topic, it's numbers in the range from -128 to 127. We have to deal with the fact that computers can only store a finite number of digits, and the number of digits we can store depends really on how many bits of memory we take up. So Java gives you several different choices so that you can make a compromise between expressiveness and compactness. So you have a 16-bit integer, and these go from -32,768 to 32,767. A lot of people by habit declare most integers to be ints, and that's a 32-bit integer. And those go from about -2 billion, which gives you enough range to do a lot of things. Did I get a digit wrong there? 214,748. Okay. But what I really would suggest to you is, by default, get it into your brain not to declare most integers as ints, but get it into your brain that long should be your personal default, because that way you're less likely to run into problems where your counter goes too high, it runs out of space, it rolls over, and then you get the wrong answer. So I would suggest always use longs unless you have a good reason for using a shorter type, like you need to store a huge array and it's taking too much memory. So longs are 64-bit integers, and I'm not even going to write how big those go. There's also floating point types, which allow you to store fractions and decimal point numbers. So the standard one you should use there is called a double, and that's a 64-bit floating point number. So if you want to be able to store numbers like 18.355 or whatever, stuff with decimal places, generally you use double, though again, there is an alternative for when you have really memory-constrained situations called float, which are 32-bit floating point numbers. Other primitive types in Java include Boolean type. And a Boolean variable can only have one of 2 possible values, true or false. And you actually write true or false in Java to give you those types. And there's also a type called char or car, depending on which you prefer, which stores a single character. Like, say, the letter H. There's also some fudgery for how you can write out numbers in Java to tell them that they're not the standard type. Now, if you just write a literal number like 124 in your Java program, that will be an int by default. So if you want to write a long number that's longer than about 2 billion, Java won't actually let you do it unless you actually say explicitly this number is a long. And the way that you write a long is you put an L at the end of the number. So 124L is Java's way of saying the number 124 represented using the full 64 bits. There is also a similar suffix for single precision floating point numbers. Normally, by default, if you just write out a number like 18.0, then Java assumes you mean a double precision number. If you want it to actually be a floating point number, well, this actually matters more if it's not a 0.0. If you want to say, I want to store 18.9 but only with 32 bits precision, then you put an F at the end. And by default, when you write a number like 1, Java distinguishes whether it's an int or a floating point number right from the start by whether or not you use a decimal point. So just to write a double or a float in Java, you should always get in the habit of always putting in a decimal point, pardon me. If you forget the decimal point for, say, an integer that you want represented as a floating point number, sometimes you'll get away with it, but sometimes you'll get bitten for it, depending on the circumstance, especially in the future when you learn to program in C. Do I have any questions on this? Yes? Oh, well, okay. This F here has nothing to do with this F here, first of all. This is not the variable F. This is a suffix that you add to a number to say, write me in 32-bit format internally instead of 64-bit format. And the reason that matters is something like 18.9 can't be expressed exactly in floating point binary, and therefore you'll actually get a different number rounded off depending on whether it's single or double precision. Question here. Well, in this particular case, you are cutting down the precision of, if you didn't write the F here, you're taking a double precision number and you're trying to fit it into a single precision variable, which means you're throwing away digits of precision. Now, I don't remember in this particular case whether Java requires you to use a cast to do that or not. I'll talk about casts in a second. But you want to be aware of when you are losing digits that you thought you had. No, the strange thing about Java is that if you just write down a number in a program, it assumes it's an int. And if you try to write down a number that's bigger than that 2 billion number there, it will actually probably give you a compiler error or something unless you put the L at the end. Now, it probably doesn't matter in this particular case. If I leave the L off here, this will get promoted when you do the assignment, but you should just get used to always knowing that when you're assigning one type to a different type, and that things can go wrong when you do that, and don't only do it when you need to, and then understand how it works. And I'll talk more about that shortly. Question here. It doesn't matter. In Java and C, lower or uppercase F or L is fine. So either of these can be in lower or uppercase. There are wrappers to turn primitives into objects. They're not that interesting to me, but... Why would you need a wrapper? We'll see examples of that later in the semester, so I don't want to go into that now. Question? You don't need an L if it's just an 32-bit number. You don't need an F if you want to store it as a double. That's right. No, it's for the 32-bit version that you need the F, actually. It's a bit confusing in that regard. Back there. Well, a double is a 64-bit number with a decimal. So you don't want to... You should always think of every number as either being an integer or a floating point type. And once you know which kind you want, then you choose from those 4 integer types or from those 2 floating point types. Other questions? Yes? No, in Java, you're not allowed to mix Booleans with numbers. You can do that in C, but in Java, they don't want you to do that. So let me point out some of the differences between the object types, or in other words, references, and the primitive types. First of all, what is actually stored in these variables? If you declare a variable of an object type, it contains a reference that points to something. And if you declare a primitive type variable, that variable actually contains a value. How are these things defined? Object types are defined by writing out a class definition, which is, we saw how to do that last class. Primitive types, on the other hand, you don't define them yourself. They're just built into Java. And you get to choose from what Java offers, and that's it. How do you create these suckers? You create an object by using the new command to call a constructor. Primitive types, on the other hand, are effectively just created when you write them down in a program. If you write the number 6 somewhere in your program, that's just creating an int right there. If you write a 3.4 in your program, that creates a double right there on the spot. If you write true, you've got a Boolean. How do we initialize them? Every object is initialized by a constructor. Primitive types, when Java creates a primitive type variable, that gets initialized to some default value, which is generally 0. In the case of Booleans, it's false. And how are these used? Well, objects, you typically use them by calling methods on them. It's the most common way. Primitive types usually manipulate with various kinds of operators. So, for instance, you can add numbers, you can multiply numbers, and so on. So let's look at those operators now. So the basic operations that we have to work with for the numerical types are you can negate a number, you can add two numbers, you can subtract one number from another, you can multiply two numbers. We use an asterisk for multiplication. You can divide two numbers with a slash. And there's also a remainder operation. The purpose of the remainder operation is to tell you what the remainder is after you do an integer division. So, now the division operation, if you do floating point number division, then you get a floating point number, but it does get rounded off because the computer can't store an infinite number of digits, and it gets rounded off to this many bits, which comes out to about 16, 17 decimal digits for doubles and 8 or 9 decimal digits for floats. But if you divide an integer by another integer, the result is an integer, so any fraction in the division gets thrown away. And so for integers, division rounds towards 0. Which basically means it rounds down unless the result is negative, in which case it rounds up because that's towards 0. For the remainder operation, well, that's an integer-only operation. You cannot use the % sign on floating point numbers. Integers only. Any questions about that? In the back there.
Will for integers return a positive integer always? Or, sorry,
the remainder will return, it depends on what x is. So if x is positive, then the remainder will be positive or 0. If x is negative, the remainder will be negative or 0. Yeah? Probably Java will give you a compile time error if you try to, say, divide an integer by a floating point number. If you want to do an operation like that, you have to convert one of the types to the other type by doing an explicit cast operation, which I'll show you in a moment. Any other questions? So these are not the only operations that Java has, but the more complicated ones tend to be held in special libraries. So for instance, the java.lang built-in library has a math class. And as the name suggests, it has all kinds of it's the first place you look for interesting mathematical functions. For instance, if I want to take the absolute value of a number, here's a way to do it. I call the abs method, which is defined in the math class. It's a static method, so you don't call it on a particular object, you just call it on the whole math class. And I feed it in a number, which could be a float or an int, and I get out the absolute value of that. And this is also the place to look for things like square root, sine, cosine, and lots of other things that you would want to call for, trigonometric, etc. functions. But sometimes operations that are useful for dealing with primitive types are found in other classes. Like the integer class has a particularly useful method called parseInt, which converts a string to an int. So So if you ever, say, read a string from the keyboard, then you want to convert it to from a decimal string to an actual number that you can do math on, this is how you do it. And there's a double class. And the double class has a similar function called parse double. Which, again, is really handy when you want to read numbers from the keyboard input. Now, there's all kinds of issues that come up in converting between different types or doing math on two different types at the same time, and I can't address all of those in this lecture. You know, if you want all the gory details, you should look it up, but I will say a few high-level points. The first is that Java will let you assign integers to variables of longer types but Java gets really afraid when you try to go the other way around and assign a number to a variable of a shorter type, because then you might be losing data, and Java wants to make sure that you really want to do that before you shoot yourself in the foot with a hard-to-find bug. So, for instance, I can say int I equals 43 and long L equals 43 long, and then, so now I've got two variables, an int variable and a long variable. And if I want to say L equals I, then that is okay with Java. And the reason it's okay is because anything that fits in 32 bits will fit in 64 bits. So the number is going to be the same number even when it's stored in L. But if I try to do the reverse assignment, if I try to write I equals L, Java is worried that I might be taking a number that's bigger than 2 billion and trying to fit it into a 32-bit box where it just doesn't fit. And if I did that, I would lose bits and have completely the wrong number and maybe have a hard-to-find bug. So Java is not going to just let me do that without any reassurance. This line is going to give me a compiler error, and Java will refuse to compile it. But what if I know that the number I have stored in L really is only 32 bits long and will fit in the 32-bit box just fine, and there are no extra digits? Or maybe there are extra digits, and I know that it's okay to lose them. And so I want to do I equals L. What do? Well, I got to sweet-talk Java into letting me have my way. And the way I do that is I say, it's okay, Java. I really, really promise you that I do want to take this 64-bit number and convert it to an int. And so the way you do that is with something called a cast. And so the cast just says, okay, Java, I've got the 64-bit number, but you can throw away 32 of the bits even if they screw up the number. It's okay. I know what I'm doing. Any questions about this? Yeah.
What if you're like long as say 3 billion and you're trying to cast it?
Well, I can't do that math in my head because it's all this base 2 number stuff. But it would be a smaller number that looks sort of random to you. In 61C, you will learn exactly how to figure that out for yourself. For this class, it doesn't really matter. Yes? Sure, yeah. You can cast between numbers more or less at will. You can cast a double to a byte if you want. And so there's a similar thing where if I have a floating point number, well, if I have a double number and I want to store it in a floating point, then I have to cast it, because I got to tell Java, okay, I'm giving up digits, but I know what I'm doing. This case isn't so bad, because at least with floating point numbers, you can throw away the bottom bits instead of the top bits. But if I want to go the other way around, if I want to store a floating point number in a double variable, then I don't need a cast for that, because any floating point number can be stored in a double variable exactly without any changes. So let's look at Boolean values now. They sound pretty simple because there's only two of them, true or false. But there are also operations on Boolean values. Booleans have operations of their own. And so I will draw a little truth table of the most important ones. Suppose I have two variables, A and B, and I write the string A ampersand ampersand B in Java. That ampersand ampersand means and, for those of you who are familiar with logic gates and stuff like that. So if A is false and B is false, then A and B is false. And we can fill out the truth table like this. So A and B is only true if both A is true and B is true. There's also a logical OR, which is two little vertical bars in a row. And so that's true if either A is true or B is true. And you have a logical NOT operator too, which is the exclamation mark, which just reverses true to false or false to true. Now, you can write Boolean values directly by just writing true or false in a program. But there are also operators that create Boolean values. And they are the comparison operators. And the comparison operators are, you can test whether two things are equal to each other by writing two equal signs in a row. This is one of the disadvantages of the design of Java and C, is that this is used for equality, mathematical equality, and a single equal sign is used for assignment. That's not how most languages do it, and it's really not a very good decision, but we're stuck with it because C became so popular. You can test whether a number is greater than another number. You can test whether a number is less than another number. You can test whether a number is greater than or equal to another number, less than or equal. And if you want to test whether two numbers are not equal to each other, the way you do it is exclamation mark equal sign, no space between them, is how you write in Java not equal. And of course, to understand these, it's best to see some examples. So, suppose I test whether 3 is equal to 5 and assign the result to x, then x is now has a value of false. If I test whether 4.5 is greater than or equal to 4.5, well, that's true. I can use expressions in here, so I can test whether 4 is not equal to 5 minus 1. And that's false, because 4 is equal to 5 minus 1. And I can even use the equal and not equal sign on Booleans themselves. So here I test whether 3 is equal to 0. That's false. And then I test whether false is equal to false. And that's true. False is equal to false. Any questions about that? Yes?
What if x equals 4.5 long, and something comes to equal to 4.5 and another one?
Oh, well, it depends on the number. If you ask whether 4.5 f is equal to 4.5, then I believe Java will take this and then convert this float into a double, and it will say, okay, now they're equal, and so the answer will be true. On the other hand, if these are 4.4, turns out 4.4 cannot be expressed exactly as a binary floating point number, so this will be rounded off, and this will be different from this, so they won't be equal. So this is where the weirdness of floating point numbers really takes over, and you'll learn more about that in 61C. Yes?
What if I compare 4 and 4.0?
Then they'll be the same. Well, okay, if you say 4 equal 4.0, I think Java might not compile that. But I don't remember I'd have to try it to know for sure. It might do the conversion. You might have to cast one of them. Yes?
What if you had 1 ampersand?
1 ampersand is what's called bitwise AND, which I'm not going to teach here, but again, it's a 61C topic. Anyone else? Yeah. When you try to compare a single precision number to a double precision number, the single precision number does get converted to a double precision number before it comparison, yes. Of course, by that time, it's already been rounded off to a single point number, so you don't get back the digits that you lost. Yes?
In the third line, how does the minus operation before the non-equals operation?
Oh, there's a whole chart of which operations get done first. So minus operations always have higher priority in Java than not equal to operations. There might be a priority chart in the textbook, but I'm not sure. If not, you might want to try to find one on the web. But when you're in doubt, always use parentheses. But comparisons are usually things that get done. Question here? Oh, you can use parentheses as much as you want, and they help a lot. So, if you're not sure what order operations get done in, just put parentheses around everything, and you'll be safe. So why do we care about Booleans? Well, because Booleans usually dictate the control flow of our program in conditional statements, like if statements. So the standard form of an if statement in Java is if some Boolean value, then perform some statements inside braces. So the way this works is Java figures out whether this Boolean value is true or false, and if it's true, it executes all of these statements. And then when it's done, it goes on to the next lines of code after that. If this Boolean value is false, then it skips over all of these statements, doesn't do any of them, but continues execution from whatever the next line of code is here. So here's a simple Java snippet that uses an if statement. So what this does is it takes your score in 61B out of 200 points, and it checks whether it's greater than or equal to the passing threshold of 75. So if you pass, then we'll write an output that says you pass the course. So that's your basic if statement. Now, with an if statement, you can also append an else phrase, which tells Java what to do if the Boolean value is false. So this next part only gets executed if pass is false. Or in other words, this is what gets executed if your score is less than 75. Right. Thank you. If-then statements or if-then-else clauses can be nested and they can be daisy-chained. So you can build up complicated decision trees by doing these things. Nested just means that you can have an if statement inside an if statement, and maybe another if statement inside that. Daisy-chained means you can follow an else immediately by another if, and therefore have more than two different possibilities. So here's some code that finds the maximum of 3 numbers. So that shows you an if-else inside an if, and it shows how you can transition straight from one else to another if. Any questions about that?
Is there a space between else and if?
Yes. Yes, there's a space between else and if. Question, yes.
Right there, the middle board,
Uh-huh.
output looks like some sort of procedure code.
Yeah.
How does it an object?
Well, because it's a static method in the same class as this code. Mainly because I wanted to avoid writing system.out.println every frickin' time. Besides if, Java also has a switch statement. Switch statement is something you use when you've got one variable that could have lots of different values and you want to do a different thing for each value. So it's a way to collate a bunch of choices without saying if, then, else, if, then, else, if, then, else, etc., etc. It gives you a nice compact way of saying things. So for instance, suppose month is a number between 1 and 12 that tells us what month it is. From January is 1, December is 12. Then let's calculate how many days are in the month. Well, if it's case 2, that means it's February. So there's 28 days in February. So that's my February case. And what break means is jump to the end of the switch clause. Now let's look at some other cases. Maybe it's April. Maybe it's June. Maybe it's September. Maybe it's November. I'm going to bunch those 4 cases together so that I can handle them all with the same code. Those are the months that have 30 days. Finally, I want to do all the rest of the cases in one blow. Java has a default clause inside switch, which means do this in all the other cases that I haven't enumerated yet. All the other months have 31 days. And that's my switch statement. Question? I don't need the very last break, but it's good software engineering practice because if you or some other coder at the same company that you work come in later and add one more case here, that break will become important. So out of habit, just always put the break there. Mm-hmm. What's that? Well, I'm not sure. It might be that the default has to come last. It might not. Java has so many rules, I can't remember them all. Try it out in your compiler and see. Question? The variable of, that's a good question. What can the variable of switch be? What can I stick here? I believe that the rules of Java say that I can use any integer type there, or a character, or a Boolean, but I don't think I can use floating point numbers there. And you definitely can't use a reference there. No object types. Question? No. The case is very limited in Java, so if you don't want to specify an exact list, if you want to specify a range like you can in Pascal, you're out of luck in Java, I'm afraid. Yes? Those are all colons after the cases. Yes. Not semicolons. Very important. Okay. So the break statements, again, let me just remind you, these jump to the end of the switch statements, of the switch statement, pardon me. If you leave out the break, the execution will flow right through to the next case. So if I were to leave out this break, I would set days to 28, Then I would just keep on going, and then I would set days to 30, and now my code would be buggy. It's a very common mistake of beginning Java and C programmers to sometimes forget some of these break statements. Then their code just runs right through into the next case, and you have a bug. So try to remember always to have your breaks in there. Java has another keyword called return, which is pretty central important. Return causes a method to end immediately when it's executed. Which can be really handy sometimes. And so the flow of execution returns to the calling method. So to give you sort of a toy example that's doesn't really do anything useful but demonstrates this idea, here's a method called myMethod, which takes a parameter x, tests whether x is 10, and if x is 10, then it just returns early, thereby skipping all the rest of the code in the method. And so all the rest of the code that's in the method gets executed if x is not equal to 10. Yes? Yep, that's the very next thing I was going to say. The return keyword serves a dual purpose. Return is also the method by which, or the means by which a method or a function returns a value. What do I mean by function? Well, you're certainly familiar with functions from Scheme if you took 61A. A function in Java is a method that returns a value. Or specifically, a method that you declare will return a type that is not void. To give you an example, let's go back to our switch statement here and turn it into a method that returns the number of days in a month. So what I'm going to do now is, instead of assigning the number of days in the month to a variable called days, I'm just going to return it. So if it's February, I just return 28. I don't even need a break statement anymore because the return statement stops execution right there and the rest of the switch statement will not happen. But I could include a break statement if I want. It doesn't hurt. Probably doesn't hurt. Same thing here. If it's a 30-day month, I just return 30. If it's a 31-day month, I return 31. Extra closing brace at the bottom. Now I've got a method that just returns the number of days in a month. Question over here?
Yeah, is there a reason why we're making the method instead of a byte?
Oh, we could make the method return a byte. It wouldn't hurt much, except that I'd have to probably write in little casts that cast all of those, the 28, the 30, and the 31 to a byte. So if I just write them on this as is, they're ints. Other questions? No. Return does not output something to the screen. Oh, well, some other function will call days in month. Like there will be a method that writes something like int d equal days in month somewhere else, and maybe pass in March. And so now you can call days in month as a function in another method and get a value back that you can use in an expression or assign to a variable.